Now we go ahead and look at exponential equations. Exponential equation. So we introduce the word equation. What that means is that we are going to bring in the equal to sign. Okay, now I want to illustrate something to you before we start looking at the examples. If I have 2, it is equal to 2. True or false? Okay, now 2 to the power 2. Is it equal to 2 to the power 1? Are they equal? No, they are not equal. 2 to the power 2. Is it equal to 2 to the power 3? No, they are not equal. Okay, now 2 to the power 2, is it also equal to 3 to the power 2? No, they are not equal. So if in an expression I tell you that what I have, they are equal, let's say in the example 1 that you see, in this example 1 that you see, if you are told that 3 to the power x is the same as 3 to the power 2, then what we have to note is that the base is the same. The bases are the same. 3, 3. And then we have the exponent of this one to be 2. Because the bases are the same, if the exponent of this other one is not 2, then we cannot say they are equal. And so if the bases are the same and then the exponents are also the same, then the expression given is true. That is why I did these illustrations here. If the bases are the same, 2 and 2, but the exponents are not the same, they cannot be equal. Because this will give you 4, but this one will give you 8. They are not equal. On the other hand, if you have them as 2 to the power 2 and then 2 to the power other 2, then they are equal. So what I'm saying is that if the expression given, the equation given, we are told that they are equal, then we don't have to bother to know x before we say it is true or false. They said it is. What it means is that if the bases are the same, then the exponent will surely be the same. So, in the example 1, 3 to the power x is equal to 3 to the power 2. It means that we can say the exponents are equal. So, x is equal to 2. That is how we can find the value of x. Okay, now example 2, the first question. 3 to the power x is equal to 9. Now when you have an equation like this, what you have to note is that check whether the other number, so in this case the 9, can be expressed as 3 to the power something, so that the basis will be the same. If so, then we can equate their exponents to get the value of x. So let's see. 9 is the same as 3 times 3, which means 3 multiplying itself twice. So 3 to the power x is equal to 3 to the power 2. And so our x here is equal to 2. Okay, now let's look at the second question. The second one. We have 16 to the power x, and we are told that is equal to 8 to the power 1. Okay, so now with this, can we make the bases the same? If you look at them, don't always assume that the base of let's say 8. The 8 is the lower one, so we can reduce the 16 to also be 8. No, they must not always be one of the numbers. Sometimes we can use a different number to get the basis to be the same. So in this case, we can use 2. So 2 to the power 4 is 16. So what I've put in the bracket is 4, the 16, before the exponent x. And then 2 to the power 3 is equal to 8. So when you multiply 2 3 times, you will get 8. Okay. Now if you remember the law, that's, I think, the third law. So 4 and x will have to multiply to give us 2 to the power 4x. And this is equal to 2 to the power 3. So if the bases are the same and the expression we are told are equal, then definitely the exponents are also the same. So here we are going to get 4x is equal to 3. So the value of x is obtained when we divide through by 4. So x is equal to 3 divided by 4. And that is how we get the value of x. I hope we understand it. Okay. Now let's take the third example. 9 to the power 4x is equal to 81. 81 can be written as 9 to the power 2. 81. So 9 to the power 4x can be equal to 9 to the power 2. That means 4x is equal to 2. So x here is equal to 2 divided by 4. And that is s is equal to 1 over 2. I hope this is understandable and that you can do the fourth example. 4 to the power negative 3x is equal to 1 over 64. Okay. Okay, so here we can rewrite 64 as 4 to the power 3. So here we will write 4 to the power negative 3x is equal to 1 over 4 to the power 3. And from the second law of indices, we realize that if we have 4 to the power, let's say a to the power negative 1, or let me use negative n, then it will be 1 over a to the power n. I hope you remember that. So we are going to convert this into this form. Okay, so we have 4 to the power negative 3x is equal to 4 to the power negative 3. I hope you agree. Good. So if the bases are the same and they are telling us that the two expressions are equal, then it means their exponents are equal. So negative 3x is equal to negative 3. And that's, if I divide through by negative 3, I'll get s to be equal to 1. So that is it. I want you to try the fifth example. Okay, now let's do it. So 16 to the power x is going to give us 0.125. So we have 16 to the power x. 0.125, if you are to write it in fraction form, you are going to write 125 divided by 1000, right? Good. So let's try to use, is it 25 to do cancellation? Okay, so when we do the cancellation, if you take your time and do the cancellation, you are going to get 1 over 8. Now when we have it like this, then we are going to use 2, because 16 and 8 can have a common base of 2. So we can write the 16 as 2 to the power 4, and then it is to the power x. And then the 8, we can write it as 2 to the power 3. So 2 to the power 4x, we are multiplying the exponent. And then this one will become 2 to the power negative 3. So if the bases are the same as usual, we equate the exponent. So 4x is equal to negative 3. And then to get the value of x, I divide through by 4. That gives me negative 3 over 4 as the answer. I hope it's understandable. Good. Now let's try this example. 3 to the power 2x minus 2, and then this expression is said to be equal to 9. So in the exponential expression on the left side, our base is 3. So can we write 9 to be base 3 to some exponent? Yes. So we have 3 to the power 2x minus 2 being equal to 3 to the power 2. That means that 2x minus 2 is equal to 2. So 2x here is equal to 2 plus 2. Our 2x is equal to 4. Our x is equal to 4 over 2. That means that our x is equal to 2. Okay, so we have other sets of examples. We have to solve. So we have 8 multiplying 4 to the power x, and that is equal to 32. So what do we do? Can we manipulate so that we get a common base for them? So if I target 4 as my base, it will not be possible, because 4 to what base will give us 8? No. And 4 to what base will give us 32? No. So we can target 2. 8 to the 2 to the power 3 is 8. So here 2 to the power 3. And then 4 will be 2 to the power 2. So we have 2 to the power 2. Let me make this a bigger bracket. And then this one is still to the power x. And that here 32 is going to be 2 to the power 5. So I've managed to change everything to number base 2. Okay, so once the bases are the same, now let me take care of what's in the bracket. 2 to the power 3 multiplying 2 to the power 2x, and that is equal to 2 to the power 5. Okay, now let's do the multiplication here. Now remember that if you are multiplying and the bases are the same, what happens to the exponents? We sum them. Good. So this one gives us 2 to the power 3 plus 2x. Okay, and that should be equal to 2 to the power 5. Now that the bases are the same, we can say the exponents are equal. So 3 plus 2x is equal to 5. And if I group like terms, I have 5 minus 3. And if I divide through by 2, my x will be 1. So that is the first example. Now the second example, 3 to the power x divided by 9 is equal to 27. So here, I think I can change 9 to 3 to the power 2, and then 27 to 3 to the power 3, which will give me 3 to the power x divided by 3 to the power 2 is equal to 3 to the power 3. Remember, if the bases are the same and we are doing division, the exponent will subtract, right? So here we're going to have 3 to the power x minus 2 is equal to 3 to the power 3. That means x minus 2, x minus 2 is equal to 3. So if I group like terms, I'm going to have x is equal to 3 plus 2, which is 5. Is that clear? Good. Okay, now let's take our third example. 2 to the power 2 multiplying x minus 3. And this expression is equal to 1. Okay, so how are we going to change 1 to have a base 2? Remember, any number to the power 0 is equal to 1. So can we write 1 as 2 to the power 0? Yes, that's very smart. Good. So we write it as 2 to the power 2 x minus 3 is equal to 2 to the power 0, which will give us 1. Okay. So this means that 2 multiplying x minus 3 is equal to 0. That gives us 2x minus 6 equals 0. 2x equals 6. X equals 6 divided by 2, which gives us x is equal to 3. If you have any question, you should be in the comment section. I will attend to it. Now the next example, example 4. 2 to the power x multiplying x minus 3. This expression is equal to 1 out of 4. So this one is 2 to the base 2. So we will also write 1 over 4 as a number to base 2. So 2x here, x minus 3 here, and then 1 over 2 to the power 2 here. So 2x minus 3, 2 to the power negative 2. Okay, so we now have x multiplying x minus 3 is equal to negative 2. So s squared, I hope you remember s and then x multiplying. That will be s multiplying itself 2 times. Okay, minus 3x is equal to negative 2. So we have obtained a quadratic equation. So we solve and get the values of x. So the coefficient of s squared is 1 and the constant is also 2. When we do the multiplication, that will give us positive 2. Now we want the factors of 2, that when we add, it will give us negative 3. What would that be? So if I multiply negative 2 by negative 1, the result will be positive 2. But when I add, I'll get negative 3, right? Okay, so I will rewrite this expression as x to the power 2 minus x plus 2x, minus 2x plus 2 is equal to 0. So I'll have x out here, x minus 1, and then minus 2 out here, x minus 1 equals 0. Okay, I'll clean this side and continue here. So now I have x minus 1 minus 2 x minus 1 again. Everything is equal to 0. So x minus 2 multiplying x minus 1 is equal to 0. So x is equal to x minus 2 is equal to 0, or x minus 1 is equal to 0. So x is equal to 2, or x is equal to 1. So that is it for example 4. Example 5. As I clean, you also work it. Okay, so example 5. 3 to the power x and then x to the power 2. And this expression is equal to 81. So the first base we have is 3. So let's target that and then convert 81 to a number, an exponential number with base 3. So here we have 3 to the power x to the power 2 is equal to 2 to the power, is it 4? Hey, sorry, 3 to the power 4. So now we can equate s squared to 4. And if I find the square root of both sides, I'll get this to be equal to plus or minus square root of 4, which means x is equal to plus or minus 2. Okay, then the last example, 2 to the power x, then that x is multiplying x minus 1. This whole expression is equal to 64. So I will rewrite 64 as 2 to the power 6. Okay, so that will be this is equal to 2 to the power 6. So that s multiplying s minus 1 will give me 6. I will open the bracket and get s squared minus x is equal to 6. So s squared minus x minus 6 is equal to 0. Now I need two numbers that when I multiply, I'll get negative 6, but when I add, I'll get negative 1. I think that will be negative 3, positive 2. So I will rewrite negative x as positive 2x minus 3x. Then minus 6 is equal to 0. So this one, I have x out, x plus 2. Then minus 3 out, I'll have x plus 2 equals 0. Okay, so this time I have x minus 3 multiplying x plus 2, which is equal to 0. So my x minus 3 is equal to 0, or x plus 2 is equal to 0. So my x will either be 3 or negative 2. Are we good? Solve the following equations. So we have equations 1 and 2. Let's go ahead and solve them. So solution. So the first equation, we have 4 to the power 2 minus x. And this is multiplying 16 to the power x plus 1. And this, the product is 64. Now what I will do is to try and write all the bases as 4. So I have 4 to the power 2 minus x multiplying 16 is 4 to the power 2. So I can write that 4 to the power 2, and these two will have to multiply x plus 1. So this is equal to 64, which can also be written as 4 to the power 3. Okay, so now looking at the expression, I have to multiply the first two terms. And as you remember in our laws, if the bases are the same, we sum their exponents. So here we are going to have 2 minus x, and then we are adding it to 2 multiplying x plus 1. And everything here is equal to 3. Okay, so we continue. So 2 minus x plus 2x plus 2 is equal to 3. Now I group like terms and do the simplification. So I have negative x plus 2x, that will give me x. 2 plus 2, that will give me 4. And this is equal to 3. So x will be equal to 3 minus 4. That gives me x to be equal to negative 1. And that is the equation to the solution to the first equation. Then to the second equation, we have 5 to the power x plus 1. And then 5 to the power x minus 1. And I am summing them. And when I sum them, the result is 26 over 25. Okay, so now looking at the first term here, 5 to the power an expression x plus 1. Now, the exponent x plus 1 tells us that we multiplied two numbers of the same base and then we summed their exponents. So this one gives us 5 to the power 1 multiplying 5 to the power x. Then in the second term, we have a similar situation, but this time it is division. So 5 to the power x divided by 5 to the power 1, which is also 5. And this is equal to 26 over 25. Okay, so now I have an LCM of 25. I'll multiply through. So I multiply 5 by 25, and that gives me 125. Multiplying 5 to the power x. Then, when I'm multiplying 5, I also divide by 5. So, multiplying 25, I also divide by 5. So here it becomes 5 multiplying 5 to the power x, which will be equal to 26. Alright, so with this, as I look at my first two terms, I see a common value 5 to the power x, 5 to the power x, and they have their coefficients. So since it's a common term, I can add them. And when I do, I'll get 130 multiplying 5 to the power x. And this is equal to 26. So the next thing I will do is to make 5 to the power x the subject, and then by so doing I divide through by 130. So this gives me 26 over 130. So 5 to the power x is equal to, now 26 goes into itself once, goes into 135 times, giving me 1 over 5. And this can be written as 5 to the power x is equal to 5 to the power negative 1. That means x is equal to negative 1. And that is it as required. Now we solve exponential simultaneous equation. So this time around, they will give us two equations with two variables to solve simultaneously. An example is what we have here. We are to solve the equation 2 to the power x plus y, which is equal to 0, which is equal to 8, and then the equation 2x plus y is equal to 4. So let's go ahead and solve. Okay, so we have 2x plus y is equal to 8. This one we can rewrite as 2 to the power x plus y is equal to 2 to the power 3. Looking at the basis, we equate their exponents to get x plus y is equal to 3, and that will be our equation 1. Then for the second one, straight away we have 2x plus y is equal to 4, and that we are not making any changes. That's our equation 2. So now we have to solve simultaneously. We can use any option we want. For me, as I look at the coefficients of y and they are the same for the two equations, I'm going to use the elimination method. So I'm now subtracting equation 1 from equation 2. So equation 2 minus equation 1. That I'll have 2x minus x plus y minus y is equal to 4 minus 3. So I'll have x plus 0 is equal to 1. So x is equal to 1. Then with x obtained, I will substitute the value of x into equation 1. So I'm substituting 1 for x in equation 1. And that will give me 1 plus y is equal to 3. So y is equal to 3 minus 1. Y is equal to 2. So this is how we solve it. The next example, if 3 to the power m times 3 to the power n is equal to 243 and 3 to the power m divided by 3 to the power 2n is equal to 9. Write down two equations connecting m and n. Hence, find the values. Okay, so the values of m and n. Solution. So we take the first equation, 3 to the power m, multiplying 3 to the power n, giving us 2, 4, 3. So we can rewrite. So let's remember that when the bases are the same and they are multiplying, we add their exponents. So we will have 3 to the power m plus n, and that will give us 3 to the power 5. From here, we can equate their exponent as m plus n is equal to 5, and that will give us our first equation. Then we look at the second equation. We have 3 to the power m divided by 3 to the power 2n, and everything is equal to 9. So we have division. If the two numbers of the same base are dividing, the exponents will have to be subtracted. So we have 3 to the power m minus 2n is equal to 9, which we can write as 3 to the power 2. And from here we can equate the exponent and obtain m minus 2n is equal to 2. And that will also give us our second equation. I hope you are following and it is understandable as well. Okay. So now we have two equations that we can solve simultaneously. Once again, I am going to use the elimination method. So I'm going to subtract equation 2 from equation 1. So equation 2 rather from 1 means 1 minus equation 2. Okay, so I have m minus m plus n minus 2n. So it's going to be minus negative 2n, which will give us plus 2n. And 5 minus 2. So here I get 0, here I get 3n is equal to 3. So 3n equals 3. I divide through by 3 and I'll get n to be equal to 1. Now, having obtained the value of n to be 1, I'm going to substitute 1 for n in equation 1, and that will give me m plus 1 is equal to 5. So m is equal to 5 minus 1, m is equal to 4. So that is it. The first part of the question says that I should find an expression connecting m and n. And so my expression will be equation 1 and equation 2. These are the expressions required. And then we go ahead to find the values of m and that of n. So that's it. Given that 3 to the power a fraction s over y is equal to a fraction 1 over 81. Find x in terms of y. Hence, find the value of x if 2x plus 3y is equal to x. Okay, so let's solve. Our solution, we have 3 to the power x divided by y, and this expression is equal to 1 over 81. We are supposed to find x in terms of y, and so I will rewrite the whole expression as 3 to the power x over y, and then this side I will convert it to indices of base 3. So 1 over 3 to the power 4. So this can be rewritten as base 3 to the power negative 4. So looking at the common bases and the fact that the expressions are equal, then we can say that x divided by y is equal to negative 4. And if that is the case, we multiply through by y, that gives s is equal to negative 4y. With this, the first part of the question is answered, expressing x in terms of y. And besides, we also take that expression as our equation 1. Okay. Then for the equation 2, we will use 2x plus 3y is equal to 3. This one, we don't have anything to do. We don't have any changes to make on it, so we maintain it as our equation 2. Okay, so now we solve the two equations simultaneously to obtain the values of x and y. Okay, so from equation 1, I have already expressed s in terms of y. So I'll substitute the value of x, which happens to be negative 4y, into equation 2. And if I do that, I'm getting 2, and then in place of x, I'll put negative 4y there. Okay, so plus 3y is equal to 3. I open the bracket and get negative 8y plus 3y is equal to 3. When I add the 2, I will get negative 5y is equal to 3. So y here is equal to negative 3 over 5. Then with the y value obtained, I can now substitute into equation 1 to get the value of x. So x is equal to minus 4y. And now y happens to be negative 3 over 5. So when I do the multiplication, s will be equal to positive 12 over 5. And I will leave my answer as a mixed fraction, and that will be 2 whole number 2 over 5. Okay, so that's it. Solve simultaneously the equations this and this. Okay, solution. We have 3 to the power x plus 1 equal to 27 to the power y minus 1. So I'll rewrite 27 as 3 to the power something, and that will be 3 to the power 3. So 3 to the power x plus 1 will be equal to 3 to the power 3 multiplying y minus 1. So I equate the exponents and get x plus 1 is equal to 3 multiplying y minus 1. I will rewrite it by opening the bracket, then grouping and that forms my equation 1. Then I take the second equation, 1 out of 3 to the power 2x is equal to 1 out of 9 to the power y plus 2. So this, I can rewrite it as this. So 1 out of 9 can be written as 1 out of 3 to the power 2 and 1 to the power 2. So I have y plus 2 here. Now I'm going to bring this 2 out. And that gives me 1 out of 3 to the power 2y plus 2. So now, since the bases are the same, I can equate their exponents, which will give me 2x is equal to 2y plus 2. So 2x is equal to 2y plus 4. 2x minus 2y is equal to 4. That gives me my equation 2. Alright. So now I have to solve simultaneously the two equations. Now from equation 1, I'll have x to be equal to 3y minus 4. I'm going to substitute the value of x into equation 2, and that I'll get 2 bracket open 3y minus 4 minus 2y is equal to 4. So 6y minus 8 minus 2y is equal to 4. Now I will group them and have 6y minus 2y is equal to 4 plus 8. That will give me 4y is equal to 12. I divide through by 4 and get y is equal to 3. Now remember that x is given as 3y minus 4. So now that I have the value of y, I'm going to substitute to obtain s is equal to 3 multiplying 3 minus 4. So x is equal to 9 minus 4, which is equal to 5 as the answer. So this is our next example. We solve, we have 2 to the power 5x plus 1 because 16 to the power 1 minus y. So we rewrite 16 as 2 to the power 4. So we have 2 to the power 5x plus 1 is equal to 2 to the power 4 multiplying 1 minus y. So now I can equate the exponents as 5x plus 1 is equal to 4 multiplying 1 minus y. So I'll open the bracket and simplify. So now this gives me 5x plus 4y is equal to 3. That will be my equation 1. Then I take the second equation, which is 2 to the power x minus 13, and this is equal to 32 to to the power 1 plus y. So I'm going to rewrite 32 as 2 to the power 5. So I'm writing 2x minus 13 is equal to 2 to the power 5, which has to multiply 1 plus y. So I will now equate the exponents to get x minus 13 is equal to 5 multiplying 1 plus y. So I will open the bracket and simplify. Okay, so from here I can write as x is equal to 13 plus 5 plus 5y. So x is equal to 18 plus 5y. That becomes my equation 2. Now I'm going to solve the two equations simultaneously. And since I have the value of x, I'm going to substitute into equation 1. So I'm substituting equation 2, the value of x, which is 18 plus 5y for x in equation 1. And so that gives me 5 multiplying 18 plus 5y plus 4y is equal to 3. So 5 times 18 will give me 90. 5 times 5, 25y plus 4y equals 3. So if I simplify and group, I'm going to have 29y is equal to minus 87. So I divide through by 29 and my y will be equal to negative 3. I now substitute y into equation 2. So substitute minus 3 for y in equation 2. That means x is equal to 18 plus 5 times negative 3. So x is equal to 18 minus 15, which is equal to 3. And that is the solution. Solve the equation 2 to the power 2x minus 5 in brackets 2 to the power x plus 4 equals 0. Solution. Now we have to factor out 2 in the first term of the equation. So we write it as 2 to the power x all to the power 2. Now this one is coming from the principle where we said a to the power m in brackets and to the power n. Then the exponent now becomes a to the power mn. That is, the exponent outside the bracket will multiply the exponent inside the bracket. And so when we have the expression like this, we can write it as this. And the reverse can also be done. So if it is like this, we write it like this, as we have just done here. So this minus 5 bracket 2 to the power x plus 4 is equal to 0. Now that we have 2 to the power x in two different terms, we are going to let 2 to the power x be equal to m. And then our equation now becomes m squared minus 5m plus 4 is equal to 0. That is, in place of 2x, 2 to the power x, we have put m. And the same thing on this side also, giving us this new equation that we have formed. So here, the coefficients of m squared is 1, the constant is 4. So we need to look for the factors of 4, that when we add, we will get negative 5. So looking at that, we will have negative 1 and negative 4. These two numbers, when we multiply, we will get positive 4. When we add, we will get negative 5. So our equation can be written as m squared minus m minus 4m plus 4 is equal to 0. Then I have m out, m minus 1 left. Then negative 4 out, m minus 1 left equals 0. So I have m minus 4 multiplying m minus 1, and the result is 0. That means m minus 1, m minus 4 is equal to 0, or m minus 1 equals 0. I hope you are following. So m is equal to 4 or 1. But let's remember that in the original equation that we were given, we didn't have anything like m. We introduced the m. So the m as we have is not in isolation. It is representing something. So now we bring back the original expression. So we can say that m is equal to 2 to the power x. And so when we say m is equal to 4, then we are saying 2 to the power x is equal to 4. And we can rewrite this as 2 to the power x is equal to 2 to the power 2. That means x is equal to 2. I hope you remember this. The bases are the same, so their exponents will be equal once we have the equal to sign between them. The next is 2 to the power x is equal to 1. And 1 can be written as 2 to the power 0. And so here, x is equal to 0. And that is the answer. Now, our next example is to solve the equation 3 exponent 2x plus 1. And then we are subtracting 28 in bracket 3 exponent x minus 1. And then we are adding 1 to it, and the result will be equal to 0. So let's solve it. Okay, so what do? Let's try to simplify each of the terms. So we have 3 to the power 2x plus 1. Now, when you see exponents adding, what does that tell you? It tells you that there are two numbers of the same base that we multiply. So here we are going to rewrite that as 3 exponent 2x multiplying 3 exponent 1. That's what this means. Then we have minus 28 in brackets 3 exponent x minus 1. This one also, if you see exponents subtracting another, it means it comes from division. So we have 28 and then 3 to the power x divided by 3 to the power 1. That's what it means. And then we continue. So for 1, we leave it as it is. I hope you get it. Okay, so here we are going to simplify again. So 3 multiplying 3x and then 2. As we just have here, we have written it as this. Okay, so we continue. We have 28. We can bring out the 3. So 28 over 3 multiplying 3 to the power x plus 1 equals 0. Now we've got 3 to the power x here, and then we also have 3 to the power s here, just like we had in the previous example. So now we are going to let p be equal to 3 to the power x. That means we are going to have 3p squared minus 28 over 3p plus 1 equals 0. So let's multiply through by 3 to make the expression look simpler. That gives us 9p squared minus 28p plus 3 equals 0. So we get two values that when we add, we will get negative 28. When we multiply, we will get 27. That is the coefficients of p squared and the constants will multiply to give us 27. Okay, so we can have negative 1, negative 27. That gives us the equation 9p squared minus p minus 27p minus p plus 3 is equal to 0. So we take the first two and then we factor out 9p, we will get p minus 3. Then the second two, we factor out negative 1. That will give us p minus 3 equals 0. So we have 9p minus 1 multiplying p minus 3 equals 0. So here we will have 9p minus 1 equals to 0 or p minus 3 equals to 0. So we make p the subject and obtain 9p is equal to 1, p is equal to 1 over 9, or p is equal to 3. But let's remember that we used p to represent 3 to the power x. So we bring back our 3 to the power x. That means that when we say p is equal to 1 over 9, it means we have 3 to the power x is equal to 1 over 9. And this we can simplify as 3 to the power x is equal to 1 over 3 to the power 2. Gives us 3 to the power x is equal to 3 to the power negative 2. I hope you remember this one. So our x is equal to negative 2. Then we have 3 to the power x. If we say p is equal to 3, then 3 to the power x is also equal to 3. That means 3 to the power 1. And so x will be equal to 1. So that is the solution. Find the truth set of the equation 2 to the power x bracket to the power half and is equal to 8 to the power x, which is also to the power 2. Okay, now let's solve. So we have 2 to the power x bracket to the power half. This is equal to 8 to the power x, which is also to the power 2. So let me open all the brackets, and that will give me 2 to the power half x is equal to 8 to the power s squared. Now I'm going to write 8 to be 2 to the power something. That will give me 2 to the power half x is equal to 2 to the power 3 multiplying s squared. And so looking at the exponent and the base, you can say once the bases are the same and there is equal to sign between them, we have 2 as the base, we have 2 as the base, and there's an equal to sign, which means they can never be equal unless their exponents are also equal. So we can equate their exponents as half x is equal to 3x to the power 2. So this is what we have now. So let me rewrite it as 3s squared minus half x is equal to 0. So I can factor out x and then have 3x minus half equals 0. So with this, x is equal to 0, or 3x minus half is equal to 0. And that means I have 3x is equal to half. My x will be half divided by 3. That will give me 1/6 as the solution. And as a true set, I have to state it as s is such that s is equal to 0 and s is also equal to 1/6. Okay. Solve the equation as we see here. Okay, so our solution, we have 2 to the power 2x plus 8, which we can write as 2 to the power 2x times 2 to the power 8. Hope you remember this. Then this is minus 32 2x. So we are not changing anything here. We are maintaining it like this, and then plus 1 equals 0, plus 1 equals 0. Okay, now for the first term, you can write 28, or I can even write the value directly, 256 multiplying 2 to the power 2x minus 32 2 to the power x plus 1 is equal to 0. And 2 to the power 2x can be rewritten as 2 to the power x bracket 2. So I can write 256 in bracket 2 to the power x and to the power 2 here. Then I continue, plus 1 equals 0. So now I'm going to let k be equal to 2 to the power x. That gives me 256k squared minus 32k plus 1 equals 0. So when you use your calculator to solve this, you are going to get 16k minus 1 multiplying 16k minus 1. That is, it has repeated real root. And this is equal to 0. So we just take 1. 16k minus 1 equals 0. 16k is equal to 1. K is equal to 1 on 16. However, our k is equal to 2 to the power x. So if 16k is k is 1 over 16, then it means 2 to the power x is equal to 1 over 16. And 1 over 16, 2 to the power x is the same as 2 to the power negative 4. That means x is equal to negative 4.